Welcome to this short presentation on probe events processing and buffering. This presentation will discuss how events per second are calculated, then how buffering can be set to improve performance and behavior. Enabling object server buffering reduces the load on the probe and the object server as events are sent periodically rather than as they are created. There are two built-in functions for calculating EPS. The load function, which calculates running average loads, the OPL stats feature that provides an average EPS. The Netcool Omnibus rules file functions include logic to calculate the event rate per sample interval. The EPS performance is affected by external calls mostly, but also by the number of tokens and the size of the tokens, as well as the rules file logic. For example, all the rules file is read as normal, even if the event is discarded at the top of the rules file. Probe buffering refers to the memory buffer the probe uses to store events before sending them to the object server. You should always set the buffer flush interval if buffering is enabled. The buffer will be flushed every buffer flush interval, regardless of the number of events in the buffer. If the number of events in the buffer equals the buffer size, the buffer is flushed to the object server. When the EPS is logged, the normal EPS can be determined. This can then be used to set the buffer properties. For example, if the probe runs at 10 events per second normally, you can set the buffer size to 100 and flush the buffer every 10 seconds.